Okay, second method we have to learn about is something called the washer method. The best way of thinking about it, think of an actual washer. If you see a washer, it's sort of like a donut hole. You have a gap going on inside. So there is unlike the disc, which was rotated right up against the axis of rotation, the washer is not. So you're going to have a gap going on. So there is a difference in the equation. You now have two r of x's. Uppercase r of x is the outer radius. Another way of looking at it, it is furthest from the axis of rotation. And lowercase r of x is the inner radius, so that is closest to the axis of rotation. Okay, so let's see. So it says find the volume of the solid formed by revolving the region bounded by these graphs. So we have square root of x, which is sort of like that, and x squared, which is a parabola centered at 0, 0, opening up. So you get this little flower petal type of thing. And we are rotating it around the x-axis. So again, there is a horizontal and vertical equation for these. I only gave you the horizontal. If it's vertical, you're just adjusting everything in terms of y. And so what you need to do is, again, still treat it similar to what we did. So if we look here, we see, all right, if we identify, say, our uppercase and lowercase r of x, again, if we're rotating it along this axis right here, furthest from that in that particular region, if we were to make ourselves our rectangle, is the square root function. So that would be square root of x. Closest to that would be our parabola, which is x squared. So in determining who is who, that's what we have. Now, in terms of parameters, still find those the same way we always have. So what we're going to do is set the two equal to each other. So we have square root of x equals x squared. Now to get rid of a square root, we square it. So we get x to the fourth on one side, and then we have to move the x to the other side. We have to factor out an x, which leaves us with x cubed minus 1, and this is all the way back to the beginning of the year. This is our difference of cubes. So we get x squared plus x plus 1 when we factor that. Now if we set each part equal to 0, first part we get 0. Second part, we get 1. Third part, you're actually going to get imaginary numbers, so it doesn't work. So the only two you have to work with are 0 and 1. So we know it's horizontal, which means here's our equation. So we have uppercase r of x squared minus lowercase r of x squared dx. So we can sub in our parameters, which go from 0 to 1. Uppercase r of x is square root of x. Lowercase r of x is x squared. Make sure, again, you're squaring them. So step 1 is to square them. So we get x minus x to the fourth. Step 2 is to integrate. So x squared over 2 minus x to the fifth over 5. And we're going from 0 to 1. We're going to sub 1 in. So we get 1/2 minus 1/5. When 0 goes in, we get 0. We need to get a common denominator. So 1/2 is 5/10, 1/5 is 2/10, and when we simplify, we get